So my talk tracks on legacy services and service meshes. So maybe just, I know it's been a long couple of days, taking a lot of information in, but maybe I could just get a show of hands. How many people are familiar with service mesh if we use that term? Who's using service mesh? So it's a good number of folks. I wanted to sort of level set so that we all sort of have the same idea and understanding. When I'm talking about legacy services, I'm thinking of those long time running applications, probably in an on-prem data center, probably VM-based, probably not going away anytime soon. They could be like a core application of your business, but someone's done an analysis and said, hey, it doesn't make any sense to refactor this application today, or maybe ever. Maybe we're going to deprecate this out. That's what I mean by a legacy service or legacy application. That's my view of that. Service meshes, I think if you did a Google of what is a service mesh, you'll get about 15 different kind of interpretations. The one that resonated with me was a view that a service mesh is a dedicated infrastructure layer that allows you to give control over how one part of an application is talking to another part. And that really kind of resonated with me. So a little bit about who I am. So my name is Marc LeBLanc. I'm a director of engineering at a consultancy in Toronto, Canada called Arctic. Work with a great team of consultants up there, helping customers kind of navigate digital transformation, modernization. Beyond that, I'm just a tech enthusiast, and that's kind of why I'm here today. I'm not talking about something my customers have done. I'm talking about problems that I see my customers running into when they're adopting this sort of technology. I like to play and work in what I've been describing this week as the art of possibilities. Like, what can we do with this? What kind of problems can we answer? With that, we're going to switch, and I have a question up here. And this, to me, this slide reads like a giant, one of these things is not like the other, right? Service meshes, microservices, Kubernetes, legacy services. If you look at those top three, like, it makes sense. We get it. We're talking service meshes. That leads into microservices, and Kubernetes is part of that equation. But why is legacy services up there? And if you think back to kind of what I was saying, how I view the legacy services, that's it. Like, it's not going away, but we still have to address it. It's still usually a core part of our business. And to kind of explain that, we have to do a little bit of a history lesson about where we are as an industry, where we're going. And I'm going to replay some of the very straight up Consul marketing materials. So I think it's true, right? We see this shift from very static to highly dynamic environments, right? So I think back to what I was doing 10 or 15 years ago, where we were building these massive data centers. I was working at BlackBerry kind of at their peak, when that's before the iPhone had kind of knocked them off of that top tier. And we were building out these massive footprints globally, right? We were kind of planning, if you had whatever amount of traffic, you would build your data centers to that with some redundancy built in. Whereas today, we're thinking highly burstable, highly dynamic, ephemeral type environments. Looking a little deeper about that. So the traditional approach, like I said, large footprint of network infrastructure. I can't even remember the amount of Cisco 6509s we'd be ordering, fleets of F5s, and this, that, and the other thing. And it was huge, complicated mess that we had to manage operationally, and just to get change out there, right? All ticket-driven processes, complicated firewall rule sprawl. This was all very real problems that the teams would face. And this is it. You would build this, and you would hope that you built enough, or that you wouldn't make the news on like a Black Friday Amazon outage sort of thing, right? You would hope that you had enough. That was a static kind of approach. And if we look at what we're doing today, we no longer have those static IPs. We're not doing that IP-based routing. We're not doing static VMs that are just up running a process forever. We're doing ephemeral containers. They come up, they do their job, they disappear. They're dynamic IPs. Your network perimeter, you're no longer in your four walls of your data center, so you don't have that north-southbound traffic where you have single ingress where you can control. So you have very unclear, murky kind of perimeter. And then obviously when we're talking Kubernetes, we're talking more east-west-bound traffic. So that's the dynamic kind of approach. So I just want to ask, how many in the room are using Consul? Okay, there's a few. Okay. So I was going to ask, and I guess there's no way to really do Q&A, but like, to me, what is HashiCorp Consul? If you asked me a year and a half, 2 years ago, it would have been, well, it's a backend for Vault. Like that's it, KV backend for Vault, that's what it does. But over the last few years, Consul's really evolved to a full-featured service mesh solution, right? And you think even back to last year at HashiCorp where they announced that there's the Consul API gateway. There's a lot we can do with Consul now. And that's going to be kind of where I'm going with when I'm talking about legacy services. There's some nuances that you get with Consul that you don't get with some of the other service meshes that I think it's a neat kind of piece of technology. So why service mesh? Why are people marching towards service mesh? Why does it matter? Right? So if you're not familiar with service mesh, some of the things we're getting out of the box with most service meshes are things like service discovery, observability, access control. This point, the fourth point on my list here, secure service-to-service communication. I'm really talking about MTLS end-to-end. This is probably the most sought-after feature that I hear my customers asking about, especially if it's in a compliant, like an industry where there's compliance regulations. They want this. This is what they're looking for. And then obviously traffic governance is something that comes into it. So going a little deeper, like what do we mean by service discovery? So if we think about what we were saying with dynamic environments, dynamic workloads, where a service can come up, do its job, and disappear, you need a way to discover where that endpoint is very quickly, very rapidly, where you can't do that if you're using traditional approaches where it's like a static IP route. That's not going to work. So a platform like Consul is going to be aware of where those endpoints are and just fire that traffic off to the right spot. Observability is just that, just giving more observability what's going into with your workloads and your traffic. Access control is like a replacement for firewalls, kind of. Talked about the secure service communication already. We're talking about MTLS from one endpoint of a workload to another. And then traffic governance, I kind of look at that as like doing some load balancing, having ways to roll out, to do blue-green deployments, that sort of thing. That's what I mean by traffic governance. And what's important to think about with service mesh is when we're talking about these features, we're talking about this at the platform level. And this is really why customers are trying to embrace technologies like service mesh. You can take the concern of those points above away from the developer, and they can assume that it's available at the platform level. So if we think about having an application that might have to be aware of some upstream service, no longer does the application have to kind of build that in and do like some sort of a health check. I'm going to put that on my mesh, and the mesh is going to figure that out for me, right? I want to talk a little bit about the experience of Consul and Kubernetes because I think it's really it's a great one. If you're not familiar with Consul, HashiCorp's done a really great job getting this Helm chart. You can go grab this one that's available on the repo, and you can have a Consul instance up and running in Kubernetes pretty quick if you're familiar with that technology. I'm not going to read through every option here, but just kind of wanted to make aware like it's a really easy, quick way to get moving with Consul. So this slide, I didn't know about the announcement yesterday that they're trying to phase out agents for Consul. So this almost doesn't ring true anymore, but that's okay. It's fun when you come to a vendor conference and you plan to talk and they've changed something you didn't know about, right? So the model that we used to talk about with Consul was that you would have service on one pod on Kubernetes running with a sidecar proxy communicating to another sidecar proxy with another service endpoint. I don't really know what it means in the new world where they're going to get rid of these agents. I'll have to go and test that out, but as of like 3 days ago, this was true. So there's a really neat feature that they have with Consul with mesh gateways. And this is a complicated slide, but I'm really just going to call out a couple of flows. So the first line I want you to focus on is that solid blue line at the bottom of this diagram. And this would be a traditional way if you were going to try to get communication between service A and service B. They would talk together, right, direct TCP ports. You'd open up your firewall, communication would happen. Cool, we know how to do that. We've seen that work. That's a model that's consistent and we get it. But with mesh gateways, if you look at the box with the 4 arrows, the 2 there, they represent a mesh gateway across a WAN of some kind that are doing the communication. And if you follow that yellow line, the solid yellow line, from A goes up to that mesh gateway, over to the other mesh gateway, and down to service B. So it's not really correct, but if you kind of think of that mesh gateway line as like a tunnel, right? So you're only opening up that tunnel, and you can funnel multiple types of service traffic across that tunnel. What that's really powerful is you're going to reduce, I call it The alternative would have been to turn your network security posture into Swiss cheese. This is allowing much tighter control over that. And so that's kind of the premise of where I'm going with mesh gateways and Consul, because you can run the mesh gateway in Consul on VMs. So if we think back to that legacy application I'm talking about that's sitting in your data center, not going away anytime soon, Consul can kind of fit that approach. What we kind of see, this is the goal I think most customers are trying to go to. Like, we're talking about digital transformation, we're talking about modernization, we're talking about, a lot of people are, whether they should or not, talking about moving to Kubernetes. All Kubernetes all the time. Whether or not that's right, that's a totally different talk track. I don't think that it always is, but it seems to be the case. So we think about federating Consul between two Kubernetes clusters. Think about that dynamic kind of model I was talking about. And this fits, right? Like you're having one set of dynamic services talk to another dynamic set of services. Consul's figuring it out for you, offering all that at the platform level. It seems like this is an obvious one that people are going for. But what I think is really happening is we move some workload, some sort of an app to microservice architecture, move it to cloud, move it to Kubernetes, and someone somewhere at a VP level says, yeah, but what about this stuff that's running over my data center that I've had running for 10 years that still is making us money or is critical to my business running, right? So this is what's happening is we're getting this POC, this cloud thing that we started as a POC, we've got it to production workload, and we say, hey, we still need to communicate with this stuff. How are we gonna handle that? And so kind of what I want to demo in a couple minutes here is the idea that we can federate service mesh between VMs and Kubernetes. Because what's neat is that control plane can run on those VMs and Kubernetes. So the fun fact here is when I first made this talk, it was a 15-minute hallway track. And they said, hey, we want you to talk for 45 minutes. I had to find additional content. And so I wanted to talk a little bit about peering, because there was a lot about peering that was announced yesterday as well, right? We're talking about the fact that Consul has peering and they can now do service failover. And I thought it was important to kind of address like why I still have a stance that I think federation has a play. So to me, when I'm thinking about federated clusters versus peered clusters, I think I'm really thinking about the management layer. Like, how am I going to manage this infrastructure? So if you think about peered clusters, you really have individual clusters that you're managing separately. So like the idea is that you have different teams that are managing their own platform and their own app, and they're choosing what services to peer with and make available across the mesh. So it's more of a distributed management approach. This diagram is terrible. This should be more of a mesh because it's not necessarily just a one-to-one mapping. Cluster 1 in this example could have been peered with both cluster 2 and cluster N. So this is what peering kind of setup would look like. Versus if I consider the federated approach, you're really talking more of a hub and spoke, where there's still a primary data center, and then you're peering with other ones accordingly. The benefit here is you could have a single team that's managing the mesh as a platform, as opposed to having multiple teams manage it. So how would you decide? I'm a consultant, so everything I answer always starts with, it depends. But the four things I would take into consideration would be, what's your organization's maturity with a technology like a service mesh? Do you really have multiple teams that could support and run it? Or do you have like the one DevOps guy that's championing it, or the one DevOps team that's championing it? That would be one thing that I would consider. Do you have requirements where the environments have to be very tightly separated? Is there a necessity that they have to be that segregated? And then you want to look how fast you want to move with this. Does it make sense that maybe you're not ready to do peering, but maybe you're going to move so quick it won't matter, right? And then the last piece, and this is probably the most important piece, and it is a huge plus for peering over federation, is the operational complexity. So if you kind of recall, I was saying that with the federated approach, you have a primary data center, okay? If you lose that primary cluster, how are you going to fail over or promote another cluster to that primary? That's a complicated thing. It can be done, but it's complicated. Whereas if you have peering, you can automatically fail that traffic over, and it doesn't matter. There's no primary in the way. So that was I just wanted to add a little bit of context around, because there's a lot of talk about peering versus federation. Peering seems to be the way that Consul is going to go in the long term. So I do have a demo. I want to do a little bit of the demo setup, explain what I'm going to show. So I've simulated a VM-based data center in GCP. So if we follow on the left, I've got my VM-based data center. I've got an application that's going to run. It's basically an Nginx front end. We're going to set up a sidecar proxy that's going to communicate across that mesh gateway to a backend pod running in Kubernetes. So let's take a look. So I'm going to run through inspecting the environment. I'm going to show kind of the mesh services that are running. I'm going to show the UI on both ends, show that we can see that bidirectional service discovery working. We're going to query a service from the VM, from the app VM. And what's really neat, if you pay attention when this runs, you're going to see that from the VM side, it's getting the private IPs returned in a DNS query. And then we're going to actually demo the service running. So I want to do a little bit more setup because I thought when I submitted this video, I would be able to pause and talk through things. That is not the case. Once we are on this roller coaster, we are on till it's done. So I'm going to forget points and I want to tell them now. So what the app is, the app that I put out here is a terrible use case, but I wanted something visual, right? So it is on my front end that I'm going to show you. It's an app that I've called Hello World, and it's an Nginx page. And the idea is it's a static service. And it's a long-running app, and it's showing a static image. This is my depiction of a sad static service that I want to modernize. And my app team has developed a random image generator running in Kubernetes private pod backend. And I want to expose that so that my app can communicate and use that as a new replacement. And so you're going to see some background, I guess. At Arctic, we use Slack heavily, and we have alphabetized our naming convention. And we have a channel called A-Team. If you notice, there's a few of us wearing these A-Team shirts that are basically ripped off the 80s cartoon, the A-Team. So I start with a Giphy of Mr. T crying because he's sad. He's on a static service. And I was talking to my daughter. I was like, hey, Maddie, my daughter's 11. I was like, I have to show this really complicated thing, but I want people to get it. Like, what could I show them that's really neat? And it's like about the internet. And she's like, well, Dad, the internet's like for 3 things. It's for Roblox, Minecraft, and Giphies of cats. Right? So I was like, yeah, I'm talking about this technology that's going to transform enterprises, and I'm going to show you Giphies of cats. So with that, I'm going to get going. I'm going to miss a bunch of points. Please come ask questions after. This is condensed to 4 minutes. I thought I built in breaks that I could talk. I was wrong. So let's go. So we start by just looking at the UI, and what we're looking at here is the UI that's running from a Kubernetes cluster. I want you to kind of pay attention that we're seeing 3 services running. There's the mesh gateway that I talked about. There's a single instance of that. We see that there's 3 Consul instances running. Is this video playing? I'm asking the guys at the back. Oh, there it goes. Yeah, okay, so we're seeing the UI from the Kubernetes side. We see those services. The mouse is gone. There it goes. Okay, so pay attention from this dropdown. I want to show that in the dropdown we can see both the environments. Just pointing out here again, those are the services that are exposed to the mesh from Kubernetes. If we go to the dropdown, I want you to see that I am in that primary data center. This is a federated setup, so we see that the Kubernetes is the primary. I'm local to that cluster. I do see that VM cluster of Consul. If I switch over there, I see the services running there. We see there's an unhappy Hello World app. We still see the mesh gateway. We see that I have 5 Consul instances, so I'm running Consul in 5 VMs. And I just want to compare here, just so we see that we are seeing something different. Hello World's happy here. There's only 3 instances of Consul. Just real quick, we're going to flip over to the VM-based UI. That's why that's highlighted there. We see this in DCVM. We see all the same services. We see the same things in the dropdown. And we're going to switch over to an SSH console in a minute. Here we are. So this is the VM-based app. This is that front-end app. And I'm just going to show a little bit of what we see. So if I do Consul members, I see that I'm on the Hello World server connected to my mesh as a client. It's part of the VM-based data center. If I do just from that client, I want to show that we see the same services on the local mesh. So the same things we saw in the UI. I'm going to do a query, and I want to just show that we can see from this VM app client that we see those services running in the Kubernetes data center. So we see that we specified, give me the services running in the DCJKE. See the same thing, Consul, Hello World, LB app, sidecar proxy, and the mesh gateway. So I'm going to just do a query. I'm going to do a DNS query just to show from the VM that I can get those private IP pod IPs. So if you've ever done DNS queries from Consul, it kind of looks like this. You just point at your local host, and there it responds. You see that with the 10 dot address. Those are those three, if you remember, there's 3 instances of that Hello World LB app running on Kubernetes. So we're going to get rid of this. We're going to take a look at the console config real quick. I don't like to do too much deep dive on this. What I want you to take away from this is port 80, we have an app running. It's called Hello World. We've also defined a sidecar proxy. And what's neat is it's the Hello World LB app. We're going to bind it to local port 8080. And I'm telling it that this service is coming from the DC GKE. So Consul's going to take this information and go figure out a bunch of things. We're going to switch over and we're going to take a look at, I told you, sad Mr. T. He's going to cry. There's a single tear. So like I said, this is, and I'm refreshing the page. I don't know if you can pick that up. The page is refreshing, and the image is the same because it's a sad static service. So I want to take a look at my app that my app developers have built. It's bound on port 88. I've exposed on a /new. It's not running. And if you remember in Consul, we had an issue with that service that was running. Hello World LB was not happy, as we see here. And if we drill down into that, I just want to show you why, because this was really important. We see that the Connect sidecar isn't listening. So we're going to go ahead and start that up. And an important takeaway with the mesh gateways is Envoy is the only proxy that supports them. That's a thing I learned when building this demo. So we have that running. So we're going to flip back over. We're going to go over to our services, take a look that now everything is healthy, because that is how the sidecar was what it was looking for, was for that Envoy proxy to be up and running. We're going to refresh this page. Happy my daughter is that there are dancing cats, and I can refresh this page a couple of times. It should refresh here now, and we can see that we're getting dynamic images instead of that same Mr. T one. Like I said, this is a horrible use case for a very complicated piece of technology, and I want you to forget about the fact that I've done this with Giphies, and imagine that this was a Vault backend, or a database backend, or a Redis backend, something that is more dynamic in nature that you want to expose and allow your old services to start consuming. And my question is, why wouldn't you do this? Because you can take your service mesh. Service mesh, one of the things it helps you with is your zero trust model and getting better security posture, right? So sure, you could take your legacy application and punch firewall holes till no end, and it will work, but you're turning your security posture into Swiss cheese. So to me, there's a lot of pros. Like, yeah, legacy applications, we kind of want to just push them in the corner and forget about them. But we can't. We have to be taking some approach to kind of pull them along into the future without taking that huge overload of refactoring when it doesn't make sense, because it doesn't always make sense. To be going to the last slide. There it is. So that's kind of the talk in a nutshell. I hope the demo kind of made sense to you. I'll be hanging out. I'd love to, if you're using this sort of tech, I'd love to kind of hear what your thoughts are, what problems you're facing. That's it.